Hello everyone, March 15th. Let's do it, a new day of LeetCode challenge. First of all, take a look here, see if anything's interesting. Trapping water, I don't really care about trapping water. I mean, it was done a long time ago. What else? I don't know this. What is this? Exceptionally fast. What is this exceptionally fast Python? Did I comment this? What is this question about? Oh, I commented something. Oh, this tortoise and hare. I remember this one. I know what this one is. This is to detect the whether a linked list has a how should I say it? Linked list has a loop. Linked list has a loop. Tortoise and hare. All right, we're not gonna care about that, and we're gonna go into today. Oh, it's a new week. Encode and decode a tiny URL. I don't think I've done this before. It sounds cute. This is a companion problem to the system design problem. Design tiny URL. Okay. A tiny URL is a URL shortening service where you enter a URL such as blah, and it returns a short URL such as blue. Design the encode and decode methods for the tiny URL service. There's no restriction on how your encode and decode algorithm should work. You just need to ensure that the URL can be encoded to a tiny URL, and the tiny URL can be decoded to the original URL. So I can do whatever I want. But it doesn't really say, it doesn't really have any requirement on the URL. So to pass this, I think we don't even have to do anything. That's my guess. I don't know. Can I just not do anything? Like encode, just return itself, because there's no restrictions. I mean, it's just to pass it, just for fun. Let's see if it passes. Does it pass? Yeah, it passed. I think this one will pass because it doesn't require anything. Yeah, it passed. Yeah, because it doesn't have any requirement. But of course, we're not going to do it this way, but just for curiosity's sake, right? For curiosity's sake. All right. Now let's think about a scheme to shorten it. All right. Let's see. So basically, it's a question of compression. Compression. What can we do to compress? Well, for one thing, we don't need HTTPS. Alright, so this we can get rid of. Oh, what is the format? What is the format of the input then? It returns a short URL such as, was this no HTTP? I don't understand. If you don't give me a format, how am I supposed to? So, which means you don't even think about the format. You just compress it. I was just talking about compressing. Well, compressing. Let me think. We need to compress to make it shorter, and then just say to make the string shorter so I can store other things. I mean, there are two things to think about, right? The original string has information, and if I squeeze it right there, we can retain the information inside the string as we return, so we don't have to store elsewhere anything else, or we can just store some external information in a class, and every time we retrieve it, we get it from the class. But that's probably not scalable. I think there's no requirement on the format. Basically, we can just say anything. We can just say foo, right? That one shall give us some. Yeah. So it's a string compression. Well, how am I supposed to know what string compression it is, right? I mean, one way to do it is to use, if we have repeated values, if we have repeated values, we can do that. So say we have double T's, we can change that into but in that case, we actually, because it's URL, right? If it's URL, then it is easy for us to identify the patterns. The URL has patterns. So the URL pattern here is it always starts with HTTP. Right, let's just assume that it starts with HTTP or HTTPS, so we can save that as a token, right? As a token, which means as we go through the original string, if we find HTTPS, so we tokenize it, right? We tokenize it, and if we tokenize it, decode and encode. So encode should give us a smaller. We can actually peek inside. Oh, we cannot peek inside. And that's one string. Like we have the consecutive values, and then we put that. So HTTP, we can replace it with one value, or HTTPS, we can replace with one value. We can actually remove it because let's just say we for this entire thing, we say it's always HTTPS : / or always HTTP : / Now we give it 2. But look at this. Look at this. Return a short URL. So short URL has to have it as well. So we don't really have to worry about this. So the input is this. The output will be the same. And then we have the domain name. Domainname.com we'll probably need to keep. Right? Because we want the short URLs to be identifiable. So the only thing we need to shorten is just this part. Right? Just this part. We basically need. Isn't that just you need a cipher, right? You need a cipher. Cipher, really? You need a cipher for this? We can turn this into something else with less values, and that's encrypt, right? That's not shorten. Well, for shortening, we need to retain all the information in this. How do we do that? What we can do is, actually I have no clue. It involves compression of the original string. Compress. And also, there's no rules. Can be encoded to a tiny URL, and the tiny can be decoded to the original URL. You're thinking like we need to record the position where these slashes are, or we have a common dictionary. We have a common dictionary of words, and then we use some symbol to represent the words. So like problems, we give a value to it, but that we will be growing the dictionary. But we anticipate. Well, can we anticipate that the input values will always be like regular words? Oh, I don't think so. I don't think this is a universal solution. How do we compress? Let's see. Write out the ASCII code. Maybe we can find something in the ASCII code. So in ASCII, an ASCII table, Okay, this is the ASCII table. It's either, so let's just say we have a problem, right? So P, where's P? P is 112, right? P is 112. So we have 112, R is 114, PRO 111, B 96, 98, problem L 108, E 101, M 109. So that's our words. Now, what I'm thinking is maybe there's some trick that we can do. Man, I think we probably should write it out in like a program. It's not gonna help. All right, let's do it this way. A equals problem, and say for letter in A, we're just gonna print letter and ord letter, and we want to print this as a binary, so we call bind. But this one will not give you. Let's do. It should be 8, right? 220. So 2 to the 8th. Yeah. So let's just do. I think it's this dot format. No, I think it's format. We call format on it, and we say I think 80b. I think that's what that is. Oh no, that is not correct. And we're doing it wrong. Is this? Yeah. It's 08b. 08b. All right. Let's see if we can compress them. For one thing, they don't need 8. They actually only 7. So we only need 7. But other might need 8. Yeah, let's just stick with 8. So this is what it looks like. Can we compress based on this? I don't know how you can compress based on this, man. They all have the same, like say prefix. Can I use that? But each one is different, so you still need 2. Compress it. How do you compress? I mean, I think the only way I can think of is like if you want to compress EE, you just put E and put a number right next to it. So if we have a gigantic number of E's, then it will be significantly compressed, right? So for example, this could be like 4E, non-I, and AK, something like that. But for a URL like this, it's basically no compression, right? But we don't really need compression like this if it's small. So maybe we just use our way, which I think probably is fine, because how can you compress this? Right? How can you compress this? Unless you, I don't know. You exclusive OR with something, but if you exclusive OR with something, it doesn't reduce the size. The size will still be the same. We'll change this text into something else. But some of the I know, like the encryption algorithm can output any length. Well, it cannot be any length, but it can output some certain length. Like if I want to expand it, or if I want to shrink it. I honestly have no good idea for this. Huh. We have a table, and then whenever each word comes, we put those words in the table. But then how do you know their orderings, right? Dictionary, right? It could only be dictionary. Yeah, I think I'll just use dictionary. And the dictionary, basically, for each word, we're gonna have a dictionary. But then it cannot handle that situation, so each one will have its own dictionary. No, I don't think that's the way to go. All right, so let's just do the way that if there are repeats, we can shrink the repeats. I mean, that's the only solution I can think of. And then when we return, we just return all the repeats. So just adjacent, right? Adjacent repeats so we can handle. But if it's gibberish, like there's no repeats, then the algorithm won't work. I mean, it's not hard to implement, right? We just read through one by one, and if it's not the same, we just add it, add it, add it. Now, if it is the same, we don't add it. We keep going until we don't have any more. So when we add is the letter and the number of repeats. But for this, there will be no such a thing because there's no repeats. And plus, you're gonna like do it for everyone, right? So EE will repeat. It's TTPS. The TT will also be considered as well. It's gonna be good to know what the actual solution is. I have no clue. This one I honestly have no clue. I'm gonna use what I'm thinking right now, but I honestly don't think that's a good idea. All right, I don't think that's a good idea because how could it be a good idea? I mean, it's very narrowly. It doesn't have any really good use case if we don't have repeats. I mean, the problem we need to solve is if the URL is super long, right? Yeah, that's the problem. If the URL is super long, super duper long, and say we have like 10 levels of URL, your scheme is not going to help if it's 10 level long. We have to like shrink it down, right? Shrink it down. But then if we do words, now we have to identify what constitutes a word. And it's not scalable because there's so many words. A dictionary will be super big for that. So that's not a solution. Let's think if there is any smart solution we can come up with. What if we do like P exclusive or R? Well, if P exclusive or R, we're going to have a value, which if I exclusive R back, we're going to get P. So P exclusive R, we're going to get a value. It's a representation of P. What if I keep exclusive O? What if I just exclusive everything? Now we're just going to get a value. And if I want to go back, we need M to get E. We need E to get L. Now we need L to get B. I think it's going to work. So if P exclusive R, we're going to have a value. And that value exclusive O, we're going to have another value, right? So if I keep O, and then this value, if I exclusive O, we're not going to get R. We're going to get a value that P exclusive R is going to be. And we get stuck here because we don't know P if we don't know R. So we have to do exclusive R to get P. So eventually we only reduce one, right? Information which is one, so we have to have everything else, and then we exclusive everything, and then that will give us a value, and that value, there's no reduction. There's no reduction. I think same with like plus or minus. But if we use, that's not gonna work. That is not gonna work. And a number of ones and a number of zeros. That doesn't seem likely either. Yeah, that doesn't seem likely either. I actually don't know. I have no clue if there's a how good a solution I can get. I really have no idea. Except from the solution I already provide, which is just shrinking the. Maybe let's just write that. Yeah, let's stop thinking. Write that. That works. That works. Although it doesn't work for this situation, it does work if we have a very tons of A's, right? So when we encode, we're just going to be rest is going to be this. No, it's going to be this. I'm going to say for rest is actually not this. Rest is long URL 0, right? And I'm going to for I in range 1 to len long URL, right? And I'm going to say if actually no. I'm going to keep it this way, and I'm going to say if long URL I not equal to long URL I minus 1, then res plus equals long URL I minus 1, then plus we're gonna have something called count. So count is gonna be 0. Right? So count is gonna be 0. So when I say count times, no, it's just plus count, right? Plus count. Let's put this count str count if count is larger than 0, else just empty string. So then we add this, right? So if it's this, then we add this. If not, then, well, if not, that means they're the same, then we increment C. And this one, after we add it, we're going to return C to 0, and this one will be C plus equal to 1. Oh. No, it's actually larger equal to 1. Then initial will also be 1, right? It will be 1. Now we know how many to give. So if they're the same, then it will be 2. Same will be 3. Not the same, then we push 3 in, and we return to 0. Yeah, so and then we are going to return this, and when we decode, right? When we decode, it's going to be rest is this, for I in range to 1 to len short URL, right? And I say if I dot is alpha, not I dot is alpha, it's short URL I dot is alpha, right? Then if it's alpha, what if it's not alpha? Yeah, we push the previous one, right? If it's alpha, then we say res plus equal to short URL I minus 1 plus int short URL I times short URL I minus 1. I don't think this is necessary, so we'll just do this. Alright. Else, if it's not, then res plus equal to short URL I minus 1. And then we return this. I am not sure. I don't know. Just run it, see if it works. No, it does not work. Does not work. Short URL. Then what's the problem? Invalid literal, but base 10. We have O passing in. Oh, there's alpha. It's numeric. Is that right? Why did I say it's alpha? Yeah, it's numeric. This one shall work. Yeah, so it works if I have input like this. I want lots of A. Like lots of A. Right, we're gonna have like say HTTPS this slash B, and then we do lots of B. Right, lots of B slash C, and consider number of C. Okay, so HTTP this .com slash B slash C. And I'll run it, and then it should give me the same result, but the short URL shall be pretty good. Wait, this is not correct. I return no. You return res. I return res. I don't know why. I return. Okay. That's not correct. That's not correct. So I shrink it to HTTP. Oh, wait. What the hell? What the hell? This is not correct. The encode is not correct. Hold on. The encode is not correct. I encoded to, it should be HT2PS and :/2 and then a110.com/b222 and C. I have C. Oh wow, there's a lot of issues here. All right, I think I'm going to do it here. I think it's possible to write test cases. Man, even this so-called stupid way is not really that easy to handle. Okay, let's put in the, yeah, I like this. I'm gonna put this one in. I think it encompasses a lot of the situations that we want to test. So we have this, and as an input, and what's the answer? Well, the answer is the same. All right. We're gonna change all this just in case a complaint, and I'm going to just say long URL, right? And this is going to be intermediate equals dot encode long URL, and then rest equals sol dot decode interim, and then rest equals answer. This should give us codec. Yeah, okay. Now let's debug. So the encode is not correct. Well, let's take a look. We say if C, because I returned C to 0, C should be actually 1. Alright, we're gonna return it here just to see. No, print just to see. No, that's not what we want. Oh, what the hell? That is not correct at all. No, this has to be 0. Why you do it? Why you do me dirty in this? Huh? How is this one correct right now? Oh, the intermediate is correct. It's this thing is not correct. Okay. Why is this thing not correct? Because I say, how does that work? Do I have to do, say, this? Nope, that's not the reason. Well, I do remember if I do 3 times, say, A, it should give me AAA, right? So this is what we do. We do short URL I, because this I is numeric, which means HT2, right? 2 is numeric, and times, that should be T. That's a TT, exactly, we have TT. And then after we have TT, we add rest to it, and that's it. But why do we also have 2 here? Alright, let's print rest HTT, and then we have a 2. How come we have a 2? Oh yes, because it says non-numeric. Okay, if it is numeric, and then we do this, okay, so we still have to use another condition. If short URL I-1 is dot is alpha, else empty. Okay, so that one helps HTTPS, but it's not helping the remaining. Why is that? So we help in HTTPS, but probably need to also print out let's print out the short URL as well. So the short URL is this, right? So HTTPS this done A. Oh, because it says 1, 2, 0. Huh. Alright, so 1, 2, 0. Oh yeah, it becomes 1, 1. Oh yeah, I see the problem. I see the problem. So we have to, if it's, alright, this is not straightforward. So it's fine, that's fine. Let's just change it. And we're gonna just say, right here, while I is smaller than len short URL, right? and we say num is 0. Num is actually 1 because 0 will not be part of it. And we say while short URL I dot is numeric, right? Num is actually has to be this. And then we just say num plus equal to short URL I, and then I plus equal to 1. So we collect all the numbers until it is no longer numeric. It gets out, no longer numeric. And oh, we don't know which one that one is. So we actually have to do J. Can I do here? I guess we can. So I should do J. So J will increment until it's no longer numeric. And then we have I and J pointing to do things. Actually, num pointing to do something. Now we say if num, then rest gonna plus equal to short URL I times int short URL j. All right. What am I talking about? Oh, I'm so sleepy. Let's turn all the num. Num has to do num str because it's not really num. It's not a num in itself. It's an str. I just say if we have, that means we have a value. Then we're gonna add this and else, which means this one is still an empty string, which means this one is not triggered, which means the current j. Well, j actually has to be I plus 1 if we think about it, because j has to be the next one. J is the next one. But we start, no, that's, is it fine? The j has to be the next one. Because well, I pointing to something, right? So the j, yeah, so I has to actually be 0, and then j will be 0.1, I plus 1. And then we check if it's numeric. If it is numeric, we increment j, and it's not numeric anymore, right? But it's not numeric anymore. Oh, then we are doing this every single time, which is bad. So let's just say j equals I plus 1. Don't be too fancy. I don't see a reason why you should do this fancy thing. So we just say not j, right? J is incrementing. So the j is numeric. Good. We num str will increment, and go to the next j. If it's not numeric, then we exit. The num str is the value, so num str can times short URL, and I will push that to res, which is if num string exists. If it does not exist, that means this while loop has never been called. Right? So the num str is always empty. So if num str is empty, which means there's only one, otherwise we will indicate. Right. So it's only one, then rest just plus equal to short URL I. So we know there's only one of these. And we're going to return until we finish the whole thing. We're going to return res. Let's give this a shot. Hold on. All right, I'm back. Man, this question is a struggle. I'm struggling because now I have an infinite loop because I forgot to increment I. I'm really struggling here as I felt sleepy, and this thing is not really working for me right now. So I has to equal to j. Now we have out of man. So because we're looking at next one, so this one actually has to be -1, right? Actually, no. We actually have to just say while j also smaller than len, short URL, and this. Spell it wrong, should be short. And we're missing the C's. Because the C's were missing in this already. Huh. How did we miss all the C's? For I in this, if this one is not equal to, and I push it, and if it is equal to, I keep going, go, and end. And we have to do plus C times is either 1, so I have to be like this. Will be I think it's this thing. It's this thing. Yeah, we have to do this one more time. Plus this, and it's not gonna be I. This is gonna be -1 because it's the last one. Plus this, if else. Yep. So this one we pass. All right. So we did reduce the length, but for a regular non-repeating like this, we don't really shrink too much, right? So, for example, if we do this, and of course the result will be the same. Let's just see if this won't work. Yeah, it does work. It does work, but I am not proud of this work because I don't really think it captures what it should be. There must be a smarter way of dealing with this. Let's take a look. Oh, we got a wrong answer. What did we get wrong? Oh wow. Oh. Yeah. Yeah, I didn't realize. Oh, and the ID equals 10. Huh. Because you're doing this, it has to be some symbols that. Man, there gotta be some symbols that's not existent in the original. What? You can't know, right? You don't know. You don't know what original symbol that is in the original one. Man, this is not easy. ID equals 10. That's very, very reasonable. Very reasonable. But we cannot handle it because we're using maybe it's time to ask for help. To ask for will be extension. Code will be extension and call as such. We need to set up something here. Let's see if we can set up something here. Then we don't need to change the original. We just index, right? We just become index. Yeah. So if we set up something here, it's like hidden, right? It's gonna be hidden. So we're gonna say self dot. It's gonna be. Let's call it shrink. It's gonna be a dictionary, right? So as we going, and if it's not the same, right? If not the same, if it's not the same, then we are going to push. Not push. So we always, right? We always going to push -1. There's no question about it. But the difference is if C, so when this difference, so we say if C is larger than 1, that means we have repeats. Then we say self.shrink index, which is actually we don't know which index it is. We don't know which index, which means we have to change this practice. We have to start from 0, right? And then we're going to do something similar to this. We don't need to call it here, which is start from 0. Actually, it has to be I. Alright, so we're going to basically change the whole setup. This is going to be while I smaller than len, long URL, right? And then we're going to say count is 0 and j equals I, and we say while j is smaller than len, short URL, and short URL j plus 1. Actually, it has to be j equals I plus 1, right? And then it's going to be j. If this equals short URL j minus 1, right? Then we're repeating. Then c plus equal 1. And we keep going until the current j is not equal to. Okay, so then we c actually has to start from 1, because when we have the first one, it's going to be 2. And then we hit everything, so we know the total number, right? We know the total number. After we know the total number, we might get to something. After we know the total number, and then we know at position I, so we do self.shrink, right? Self.shrink I, position I equals C. We know how many letters are in this position. And if C is, and then we actually say if C is larger than 1, then we do this. If C is not larger than 1, then there's no reason of doing it. Right? There's no reason of doing it because there's no savings. No savings. So if C is larger than 1, then we save it. And we also increment I is going to be j. Come back up, do this again, and then we'll find that it's already is not equal. Then we come out, and C is 1, and then we don't do it, we keep going. So that is the encoding, right? So we're basically pumping out this thing. And then after we're done, what about the rest? Did you forget about the rest? And we have to increment every single time the rest. So rest is plus equal to short URL I. So we're going to return rest because we actually go to the end. So that's that. And when we decode, it's going to be rest and this. That's good. And we don't have to do this because it's contained in here. So we're going to say if it's not if, it's always rest going to plus equal to short URL I, always going to be this. And then we're going to say if I in, actually no, let's not do that. So if I in self.shrink, if it's in it, that means we have something to do. So we're going to say rest plus equal to short URL I times self.shrink I. right? But this one can be further getting down. I'm going to say self.shrink dot get I1. And oh, we actually can just say for I. Oh, it cannot be. Oh man, because the index are not the same. If you save the index, then we don't save that index. We save the index corresponding to the short URL, right? So instead of I, it should be the URL, which means this should be len res, right? If it's the first one, then len res will be 0. That's good. And then if we add one, do we add one first or? Yeah, I think it's actually better. We add this one first. So we add it first, right? And then we always do -1. So that is the most current one. So then here we can call I, right? Then here we can call I, and basically either it's 1 or it's good. So we don't need all this, and we also don't need this because we can just do for I in range this, and we don't need this, and we don't need this. We can test it. Self is not defined. I think this is just shrink. Short URL is not defined. It's not short URL, it's long URL. Pretty sure it's long URL. Name short, the short URL again? Why, man, you are not going to like this. I did short URL so many times. And this is the infinite loop. We have to fix that. But it's what the problem is? This the problem? Oh yeah, it didn't increment. Actually, do we even need J? Right? C is already incrementing every time, so we don't even need J. So we can just say I plus C, right? I plus C, and then I plus C, and this one is just I, because it's not going to change. All right? If it's equal to I, and then we increment, and then next time coming up, it's also compared to this, and only one is not. Then we come out, rest, gonna put I into it, and let's say if C is larger than 1, then we're gonna do this equals C, and then I need to be equal to I actually is plus equals C, because we go so many times. Alright, do this again. We passed the first one, but we failed the second one. We were told, oh, what the hell? What the hell was that? Alright, we passed the first one, but we failed the second one. Okay, let's double check on the second one. So the second one, everything got expanded. That's when we use, I think it's the problem of, I actually don't know what the problem is. So HTTPS is correct. And then we do L, right? And then we have an issue. So first of all, we don't need J anymore, right? This one does not. Oh! It's J. Why would J be an issue? I don't know. It says it failed. Oh, because it's using the same one. That's why it fails. Ah, I see. I see. I see how it is. So we cannot share. So everyone need to get a new one. Every time I call in code, it will get a new one. So it will be self dot shrink equals this. Yes, now we're talking. So everything will get its own. Again, I feel I feel like a hack. Feel like a hack to me. I run code. Oh, actually, when I run this, yeah, I'm gonna put it here. This is considered a failed test, so we're gonna. Oh my goodness, why? Why do you use this? Change that into a single quote, and I'm gonna run it. And I think I passed. This one shall pass, but I don't like it. I don't like it. I don't like it. I don't like it at all. I'm gonna have to take a look at the actual solution and then see. Ooh, terrible runtime. All right, let's see. Let's see what the good runtime is. What the good solution is. Okay, I wanted to say a little bit summary. I do not like this solution. It uses a separate dictionary to record the number of times any letter repeats itself consecutively. And by doing so, we avoid writing the same letter repeatedly. We avoid writing something like all letters will only appears once. Let's just say we avoid writing repeatedly. During decoding, we check the dictionary to see whether any letter has more than one consecutive repeats. If it does, we expand the letter. I don't like this solution because it doesn't seem to me, it doesn't save any space. We basically uses a dictionary to save the we basically use external memory to save to seemingly reduce the size of the input string, while in fact nothing has shrunk. It's ON solution, but it's 44 milliseconds. I am okay to report this only have 14%. I mean, technically speaking, if we run this for the first time, it might be a bit higher, but nah, I don't like it. I don't like it at all. All right, no more grumpiness. Let's just go and take a look at the actual solution. I am curious. I'm very curious how this one is actually implemented. Let's see. A lot of download. Let's see. What's the... Okay. I first produce a short URLs like this and this. Using increasing number of code that is simple but has some disadvantages. So it just appended it, and oh, so this type of usage is not discouraged? Yeah, I think we just got confused. Okay, several entries, wastes. Yeah, there's a waste. How do you determine? Oh, we use this. We use this as okay. That's fine. How many URLs are already being coded? Not sure I want them to know. People might try to get special numbers. PD request shortly before the design number comes up. Codes can grow and very large. Millions of code with length 6 or smaller. What does that mean? Only using digits means the codes can grow unnecessarily large. Only offers a million code with length 6 or smaller. In the 6 digits or lower or uppercase letters would offer this many codes with length 6. Oh, wait, what is this? Amazing, not a one-liner. I don't understand the last sentence. I mean, basically, what it's trying to say, so use random number generator. Is that how it's, so we do save something. I thought you can just convert it. Oh, I guess I'm wrong. You cannot just convert it. You have to use some trick. It's basically a hash map, right? You're producing a hash map. And then you're hashing the last part. And only using digits. What do you mean only using digits? You mean like digits for this? Only using digits means the codes can grow large. What do you mean the code can grow large? A million code with length 6. Length of what? Yeah, he is so cryptic, I cannot even understand. Using 6 digits or lower or uppercase letters would offer 10 plus 26 times 2. That's all, that's everything. Yeah, that's, if 6, we're talking about like 6 digits here with length 6. Using 6 digits or lower. Oh, I know what he's talking about. Now I know what he's talking about. He's talking about you're using actual digits here, actual like numbers here, but if we have 6 here, we can only store a million codes. But if we use like a random for 6 letters, then we can save way more codes, okay? And then you just need to design a way to do this. And I think you just have to, a random number generator, right? So it's based on the long URL. Actually, it's based on what do we base on? The current position, right? Based on the current position, we just need to generate a unique string. And yeah, we just need to generate a unique string. Each time that a new one comes in, we generate a unique string, and that string will be attached to this, and then okay, so I know what this is. Randomly generate code is already generated before, so we just generate again till we have code that's not already used. Using half of the code, which is a whopping entries, then each code has a 50% chance. So the expected average number of attempts is 2. However, only 1 in a billion takes more than 30 attempts. And if we ever get an answer larger, and we just use 7 out of available codes. Now I understand what this question is actually asking about. This question requires more, I would say, more explanation. Yeah, this is my initial solution. Somebody else did this as well. 3 different approaches. Oh, okay. Hash code. Oh, okay. Hash code. This is the internal hash code, right? Yeah, this is a random function. That shouldn't happen. That shouldn't happen. All right, so it pretty much converges on the actual solution. I understood the question wrong. I think, man, the question is actually asking you to turn this into this, specifically, tinyurl.com/something. That's what is asked. But I thought it's just anything, turn into anything. And I was also struggling because I thought there exists a method to actually shrink this, like for real, to shrink this thing down to this using some type of scheme. But apparently it's not. I mean, it's just it's a hashing. You hash this thing to something else. I mean, it could be a hash function, but more realistically, you use a random. You generate a random string. That's more realistic. You generate a random string that's specific to the position. It has also something to do with the position, which is, to think about, is quite ridiculous. Actually, it's not ridiculous. It's all right. It's all right. You use this as the key, right? And then the value is going to be no. It's you use this as the key, and this is the value. Why do they need 2 dictionaries? If I have this is the key and this is the value, so I'll input this, I generate a key for this, and I put this as a key and this is the value. So when I come out, why do we need 2 dictionaries? I don't understand. They use 2 dictionaries, right? They say like 2 dictionary solution. What is the requirement for 2 dictionaries? I mean, they are already doing all these fancy stuff. I don't understand. But we're gonna try it. And import random. So this one requires internal state. So basically, I misunderstood the question. I seriously misunderstood the question. So I'm going to def init. Actually, maybe we can get rid of we probably can. So we're going to say keys. Keys and the long URL. Equals, this is going to be the dictionary, right? So we're going to say when we encode, we're going to produce a key. We say while true, right? We say key equals. We're also going to have the alphabet. Yes, alphabet equals. How do we do alphabet? A to Z. Wait, does Python has ASCII? Maybe they do. Oh, it has ASCII function. No, I don't want to get a. I want to get all. Okay, what does this function do? Escape? No, that's not what we want. Get all alpha. That's like all letters. I don't know. Is there like a built-in function for this? Alphabet range. Oh, that is okay. String does this. All right. Apparently that. Oh, uppercase digits. Oh, hexadigits. Printable. Man, that's way too much. So it's going to be letters and digits. So alphabet equal to string dot ASCII. I'll probably have to import string. So let's import string. Import string. And then string dot ASCII letters plus string dot digits. I'm gonna upvote this one. Good question. 7 years ago. And then when we do this, so key would be random dot choice sequence, a random value from the empty num-empty sequence. So we're going to choose from alphabet, but only choose one thing. Right? I need to read it. It has to be random choice. This sequence is like it doesn't have to read the documentation. All right, where is the choice? Choice. Okay. Choices. Population weights. Cumulative weights. K equals 1. Return a k-sized list of elements. Oh, we should do choices. Choices. Alphabet. The weights is specified. Our weights is not specified. We don't have weights. And return k size. So we put k. So we're just given a k. K equals 6, right? So we get a key, and we say if key not in keys URL, then we're gonna break, right? So we break out when we say keys key equals long URL, and when we return, tiny URL. Wait, what do we return? We return this tiny URL slash plus key, right? So that's what we encode. Now when we decode, when we pass in this, we first need to find the key. So we say key equals, we can just do short URL del split, and we say split based on this, and we pick the last one, and we're gonna return, right? When I return keys this, and then we do this, and then we're done just by doing that. Alphabet is not defined because alphabet has to be self.alphabet. Keys is not defined because it has to be self dot keys, and here is the same thing, has to be self dot. And the unhashable, it's not key, it's going to be this dot join key. If, oh my goodness. All right, I'm gonna do it here. Dot join this, and then we don't have to use this. It's still key. Health. There we go. Redefinition. Okay, so we can put codec 1 and codec 2. But again, I don't understand why did they use 2? I mean, if we go down this route, I think it's perfectly legal just do it this way. I mean, I don't see any reason not to use. I mean, we're already going down this way, right? So I guess it's fine. Yeah, I guess it's fine. Why using? What's the reasoning for using 2 dictionaries? For example, I think C said use 2 dictionaries as well. Short and long. Why using 2? To make it yeah, the short long and long short. Oh, so that you do, I don't know, short long short the long URL, so we get a code, okay, and we're gonna get short long, so short, we're gonna get a code. I don't know. They do it that way, but then I realized because we set k equals 6, so we actually don't even need to do it this way. That's true. We just need to do what? The -6, right? Yeah, that should be done. Okay, so apparently I have misunderstood the question and thought and made it too complicated. I thought there exists a method to actually shrink a long string into a short string. But it turns out the converged method from most people uses additional dictionaries to save the mapping between the short mapping between the short and long URL. With such use of external dictionaries that directly performs hashing, the problem is actually quite trivial. It's actually trivial. We simply produce a random string of size 6. Well, why size 6? Because the example shows that the short URL has the last part with size 6. A random string of size 6, and use that as the key for the long URL. Then we simply store them as key long URL pair. And that's it. When decoding, we look for the key from the end of the short URL and obtain the long URL from the dictionary. All right, that's it. ON. Oh, that's actually not ON. I think you can say it's ON. 36 milliseconds, and we run at 52%. This is 52% ranking. Again, I mean, just a little bit misunderstanding of what this question is actually asking for. Yeah, like I said, it's quite trivial once you know what it is asking for. It's very trivial, but I don't like this question. I think it requires more, I should say, description. I would like this question to be more specific on the requirement. For instance, is the use of additional more specific on the requirement. For instance, what is the required? Actually, I mean, in that case, what is the required? It didn't even say what is the required short URL format. What is the required short URL format? Is there any restrictions? But it does say you can design anything, so I guess there's no restriction. Yeah, I think the only thing is what is a short URL format. Yeah, let's do it that way. All right. Wow, it took a long time on this actually very trivial question. Feel bad. Tomorrow we're gonna have revenge. All right, that will be it for today. Adios.